I've been studying PostgreSQL because Hello Interview recommends it as one of its top database recommendations in interviews. So one of the things I want to be able to understand fairly well is when to use it, obviously. And a topic that I didn't see heavily covered in their materials, and I haven't didn't find an obvious good resource for off the bat on YouTube, was concurrency. I was a little bit confused about this topic, which is why I went digging into it. And so I'm just going to shoot a little video on what I found. Maybe I'm duplicating, material that's out there that I just didn't happen to find. But I wanted to shoot y'all a little video just in case this is helpful for you. So let's jump in. So concurrency is all about what happens in your database if there are multiple transactions happening at the same time. And so in terms of a system design interview, this is important because the kind of question or problem you're trying to solve, if you're going to recommend Postgres, you want to have a good reason. And so the most important thing, I'm just going to say it off the bat here, that I learned, and then I'll go into a little bit of the why as best as I understand it, is that if you're solving a problem, that it absolutely needs to guarantee that the transaction goes through. So the way that I am talking about it here is that the problem that you're solving, your business would be adversely affected if this transaction goes wrong. So banking transfers, inventory reservations, so like your Ticketmaster questions, your Stripe questions. This is where you want the highest isolation level. Isolation means like transactions isolated from one another. So the highest transaction level in Postgres is the SSI, or Serializable Snapshot. I'll go to the lowest next and discuss that, and then we can kind of talk about what's in the middle. Let's say you're dealing with most problems, right? Like showing something on a UI, a heavy read problem. This is where the default level in Postgres is totally fine, and it gives the best trade-off in terms of balancing the performance and like concurrency. So it's called read committed. Now in the SQL specification, they'll also talk about 4 levels, which includes read uncommitted, but that's really implemented as read committed in Postgres, so you can kind of collapse those into the same thing. So the important thing, the reason that you can use this for most problems is that it does protect from what's called a dirty read. So a dirty read is reading uncommitted data that could be rolled back. So this means that at the sort of lowest level of transaction isolation and the default level, the data being read could change in the course of the transaction, but we're okay with it because maybe it's just something like showing a user's showing a user social media feed or something like that. So not something that's going to have a adverse consequence beyond annoying people if something goes wrong. So the situation that kind of falls between like the highest level of isolation and the lowest level, so between serializable and read committed, would be repeatable read. And so what this is useful for would be like some financial calculations, some order processing, things where you don't want the data that you're reading to change while you're executing your transaction, but you might not need this complete transaction isolation guarantee. The very occasional chance that something goes wrong is not going to be absolutely critical to your product or business. So let's jump in a little bit to talk about how each of these work differently from one another. So the read committed basically what it does is it uses a new snapshot for each statement, so transactions only see committed changes, which is different than the repeatable read, which uses a single snapshot for the entire transaction. So this difference, so these snapshots are like snapshots of like the database state, and so with the read committed, each time it's doing something, it's looking at a snapshot of the database as soon as it starts its query. So what could happen is that as it goes line through the query, it could be the case that some other transaction changes some of the data and that's in the database. So it could read information in the course of processing that has changed because another transaction has changed it. Whereas if you use a single snapshot for the entire transaction, that just can't happen. So this gives some protection from non-repeatable reads, and it also gives some protection from phantom reads. So the difference between non-repeatable reads and phantom reads, non-repeatable reads would be reading something in the database that, like a row, that gets changed by another process, whereas a phantom read involves reading, like it might involve executing a query that some of the information underlying that query gets changed in the course before the results returned. Postgres protects from some of these kinds of reads at the repeatable read level, but not all. The only level that will protect from all of these cases is the serializable snapshot. And so what the serializable snapshot isolation, SSI, does is it actually has it has ways of checking concurrent transactions to see if they are making changes to the database, and it will only allow one of those transactions to complete. It has some rules that it follows. We don't need to delve into them, but the important part to know is that it does follow some rules, and that only one of those transactions that is attempting to make a change will be successful. Otherwise, what happens is that one of the transactions will fail, and it will send a serialization error back to the application. And so then from here, this is another important point in the system design interview, is you want to mention that the cost of this is that the application is going to need to be able to handle these transaction failures, and so the application side of the code needs to deal with serialization failures when the transaction doesn't execute because something else was changing it and it was the unlucky one. So yeah, that's about it. I'm just gonna leave it here and hope that this is helpful for you. If you'd like to see this table, as well as all of the other resources I have on system design, including strategy notes if you're studying system design, book recommendations, lots of stuff that I've received through mentorship that I'm just happy to pass forward and help out other folks that are trying to learn this topic as well. Feel free to visit my website. And the other thing I can, of course, very highly recommend is the website Hello Interview. So thanks for listening. I hope this helps. Let me know in the comments if you have any questions, or if this video is helpful for you, and feel free to, I guess they say, like and subscribe for more content.